Hello everyone, welcome you all to my YouTube channel. I am Sayani and I am back again with a new civil engineering video. If you are new to my YouTube channel, please don't forget to subscribe to my YouTube channel Sayani and press the bell icon for instant updates. In this video, we will study the different types of foundations in detail. So, foundation is the most important part of any structure. The strength and the durability of any structure depends upon the strength of its foundation. First of all, we will learn what are the different types of loads acting on a foundation. The first one is dead load. It is the load of the materials that are used for various components of a building like walls, roofs and floors. The next one is live load. Live load is also known as superimposed load. The live load includes the load of persons standing on the floor, weight of the furnitures or any other materials that are temporarily stored on the floor. The last one is wind load. The provision of wind pressure should be made according to the prevailing bylaws in the locality where the building is to be constructed. On the basis of the nature and the depth of the foundation is generally categorized into two parts. First is shallow foundation and the next one is the deep foundation. In this video, we will learn in detail about the shallow foundation, and in our next video, we will learn about the deep foundation in detail. So first of all, we will see what are the different types of shallow foundation. So first one is isolated foundation or isolated footing. Second is combined footing. The third one is trap footing. The fourth one is mat footing or raft footing. And the last one is inverted arch footing. So we will learn about all these types of shallow foundations in detail. So let's start the video. The first type of shallow foundation is isolated foundation or footing, and isolated foundation can be of three types. It can be a pad footing, it can be stepped footing, or it can be a sloped footing. Now we will see when isolated foundation is used. It is generally used when the SBC or the soil bearing capacity of the soil is high and it comprises of a thick slab which can be flat or it can be sloped or it can be stepped. It is used when the load on the footings are less. Isolated footings are also generally used if in case of a building the columns are placed at larger distances. Generally, an offset of 15 cm is provided on all the sides of a concrete bed. In case of brick masonry columns, an offset of 5 cm is generally provided on all the four sides in regular layers. Now we will see how the size of a footing can be calculated. It is calculated on the basis of area of the footing equals to load carried by the column by the safe bearing capacity of the soil. The next one is combined footing. Combined footing generally supports two or more columns in a row. Now, a combined footing can be rectangular in shape if both the columns carry equal load, or else it can be a trapezoidal footing if there are space limitations and if the columns carry unequal loads. Combined footing is used when a column is placed very close to the boundary of a property, and in that case there is no scope to project it much beyond the column face. As told earlier, there are two types of combined footing. One is the rectangular combined footing and another is the trapezoidal combined footing. The next type of footing is trap footing. So, if the independent footings of two columns are interconnected by a beam, then such type of footing is known as a strap footing, and this beam is known as a strap beam. A strap footing may be used when the distance between the two columns, that is column A and column B, is so more that a combined trapezoidal footing becomes quite narrow with high bending moments. In that case, each column is provided with its independent footings, as you can see in this diagram, and a beam is used to connect these two footings. This beam is not in direct contact with the soil. The strap, assumed to be infinitely stiff, serves to transfer the column loads onto the soil with equal and uniform soil pressure under both the footings. Generally, columns are supported on column footings, but in conditions where columns are located adjacent to the property line, in that case the column footings may be offset so that they do not encroach into the adjacent property. This results in an eccentric load on the portion of the footing, causing it to tilt on one of its sides. The strap beam restrains the tendency of the footing to overturn by connecting it to nearby footings. The fourth type of shallow foundation is raft or mat footing. So first of all, we will see the diagram of this raft footing or mat footing. Now this raft or mat footing is basically a continuous thick concrete slab on the soil that extends the entire footprint of the building, and it increases the SBC or the soil bearing capacity of the soil. Now we will see where this raft or mat foundation is generally used. So raft foundation is generally preferred when the soil bearing capacity is very low, when the load on the structure has to be distributed over a larger area, as you can see in this diagram. When a column is placed near to a property line and the walls are so close that the individual footing would overlap. When the stresses on the soil needs to be reduced. When there is a possibility of differential settlement in case individual footing is used. It is also used if a basement is to be constructed. Fifth and the last type of shallow foundation is inverted arch footing. So first of all, let's see the diagram. Inverted arch footing is generally used on soft soils to reduce the depth of the foundation. This type of footing is also used in such places where the SBC or the soil bearing capacity is very poor and the load of the structure is concentrated over the walls and where the deep excavation is not possible. A great disadvantage of this inverted arch footing is that the end piles have to be strengthened by buttresses to avoid the arch thrust tending to rupture the pier junction. But the advantage of this footing is that in soft soils the depth of the foundation is greatly reduced. The end columns must be stable enough to resist the outward pressure caused by the arch action. Thank you all for watching this video. Please subscribe to my YouTube channel. Please like this video and share it with your friends. Meet you all soon in a new civil engineering video.